Welcome to the stream, everybody. I really want to make an intro GIF that's set specifically to this song, which is so badass. Fills me with energy, makes me feel excited to stream. You know, we're like hopping in our cyber truck, getting into the road. You know, we got our like hacking computer sitting around in the car, and we're just about to go at it. You know, driving through the desert, figuring out stuff to work on or whatever. You know, like a loyal dog in the passenger seat, a couple homies in the back. Yeah, that's how this song makes me feel. Welcome to the stream, everybody. I hope you guys are all doing great and having a good Friday. For me, it's been a good week. I feel like there's been a bit of, just for me in my life. What happened? I went on vacation like a month ago. You guys remember that? Went to Cape Cod. I did a live stream from a car. It was super fun. I feel like after I came back from that vacation, it took a little while for me to get back into the swing of things at work. I feel like, I don't know, I just was feeling a little bit sad, maybe, or a little bit like, I don't know. I just wasn't feeling great. Does that ever happen to you? You know, I feel like once you come back from vacation, there's a little bit of moment where it's like getting back into the swing, you know, getting back into the grind, understanding what you're doing at work. For me, this time it lasted like kind of a long time, like several weeks. It was weird. I was concerned. I was starting to feel like, what is going on? And then everything kind of came roaring back all of a sudden. I don't know what it was. I don't know what it was exactly, but it did all come back and it felt good. You know, this week has been, I felt really motivated. You know, maybe what it is we're kind of doing some planning for the next release of CockroachDB, as we usually do around the time as we're about to release the last release of CockroachDB. It's kind of a fun thing. You do a little planning, and at the same time, you have to do releasing. So it's always a bit of a stressful time, but for me, this time around, this week, thinking about that planning, just kind of getting my mind back into the mindset of what is the next scope of work. That got me, I don't know, got me back into it. So I'm feeling good about that. And yeah, I don't know. What have I learned? I've learned that sometimes it takes a little bit of time to recover from a vacation, like a little post-vacation vacation. Sometimes you need something like that, but that can be hard if you didn't take the time off. But yeah, so I don't know. That's what is up for me. I think that in terms of other things, what else? I saw Goodfellas last night. You know, guys, I've been on a Sopranos kick. I think I mentioned that. You know, eating that gabagool every day, thinking about whacking mob members or whatever. And it just so happened that in New York City, Goodfellas was playing at Film Forum. I don't know if you guys know Film Forum. It's just kind of some art house movie theater. And my friend invited me. You want to go see Goodfellas? And I said, you know, that would be great. I would love to see Goodfellas. Never seen that movie. And good God, if you guys are Sopranos fans and you haven't seen Goodfellas, what a weird experience, because all of the characters from Goodfellas went on to work in The Sopranos. And I'm talking like a lot of them. Like the therapist is a major character in Goodfellas. You got Paulie, he's a major character in Goodfellas. You got like Carmine, he's in Goodfellas. And then there's probably a couple of other major ones that I'm forgetting. But anyway, it was kind of a trip. Great movie, a lot of fun. I actually like The Sopranos better, but I kind of enjoyed watching it anyway. Funny how, exactly. Hey, Matt. Hey, Kadobes. Hey, Saved. You found out this week that your town is apparently run by the mob? No way, dude. That is not, can't be, couldn't be. And if it were the case, then why would you be telling me on the public internet? You're gonna get in trouble. The mob doesn't like to be implicated in having shops. A lot of shops downtown going in and out. Nobody going in and out. What is up, Adrian? Whew. Yeah. Well, you never know. I mean, I think here's the thing. Like, you got mob people. You got mob people, and you got their mob people's children. What do you think the mob people's children are up to? They've got to be hanging out. They've got to be video gaming, right? You know, AJ? AJ loves to play video games. And here in the modern world of 2021, there's a lot more video games to be played and a lot more video games to watch. right? And so since you're on Twitch, obviously you're going to come to this channel, right? Because everyone on Twitch basically checks out this channel at one point or another, right? So odds are Kadobs, that you know, those mob folks are just hanging out in here with you. But anyway, what is up, Lisa, Pratik? Hello, Alan, Akioli. Welcome to the channel, friend. It's good to see everybody. Little town called New York City, baby. That's right. That is exactly right. So I took a shower, by the way. That's why my hair's looking a little like, I don't know what it's doing right now, but it's freshly wet. You know, it's not oil, in case you were wondering, in case you were freaking out, like, Jordan, wash your hair. No, I just did wash it. How about that? How about that? You were in Brooklyn once and went to an Italian restaurant near JFK, which is in Queens. Okay. I don't remember the name, but it had a Sopranos vibe. You know, okay, let me show you the best Sopranos vibe place that I know of in Brooklyn. It's called, let's see, we'll go to maps. So if you go down over here to Court Street and you zoom way in and you check out this place called Sam's. Okay, you guys see this place? You guys see this place? Sam's, baby. Look at this. Okay, so basically you walk in here. You walk in here and you basically are in a mafia town. You know what I mean? You like all of a sudden are in the freaking mafia. I'm not kidding. We got like carpeted floors. We got red tablecloths. We got it all. And here's what's more is when you're going to eat in there, you actually have people just like chilling with cops. We got Italians chilling with cops. I kid you not. One time I was eating pizza in here. Cop walks in, shakes the hand of an Italian guy. They sit down, they shake hands. They dine together. And I'm like, holy shit, this is intense. You know, maybe they're just friends. But anyway, I recommend checking this place out. It's actually really good. Yeah, and apparently George Lucas is a fan. Look at this guy. George Lucas is chilling right outside of Sam's. But anyway, so this is Brooklyn, you know. This is Brooklyn. A lot of good stuff on this street. Great movie theater right here. You know, you can watch Toy Story 4 if you want. Anyway, that is not the point of all of this, really. That is not the point of this, really. Patrizia's also has a pretty excellent Italian restaurant vibe, more in the way of what the Olive Garden pretends to be in the commercials. I don't know what Patrizia's is, say, but it sounds good. Now I'm afraid of leaking my address though. So Patrizia's of Sheepshead Bay. There's a lot of Patrizia's. The one in Williamsburg. Well, I gotta see the street view. Oh God. No. Apparently in incognito mode, you can still see where the location is. Oh well. So here's Patrizia's. It looks like a place, you know? It looks like a place. Well, cool. If you guys are ever in New York, hit me up and we're gonna have some mafia pizza, basically. We're gonna have some mafia pizza. JS Lynn, what is up? Welcome to the stream. It's good to see you. Thanks for stopping by and saying hello. Time Frog. I should update my little project. I think it's a little different. It's kind of the same. We worked on this last week a little bit. JSON functionality, but we're gonna continue it. We're gonna do a little different stuff, but that's I should probably update that. Hi there from TGV. What is TGV? Lots of big, loud singing families. Okay, so let me update my project here. Project, commands, edit, project. Adding compatibility for Postgres to CockroachDB. Never heard of Cockroach, but wow, they've got some high revenue numbers. That's right, baby. Great database, though. You should check it out. Excellent database. TGV, a train. That is cool. So you're connected to us via high-speed internet from a train. That is pretty badass. Spotty internet will not hear everything. Yeah, I get that. Okay, so let's dive into it. Let's dive into it. There's been enough address leaking and pizza discussions for the time being. So here's what the project is all about, you guys. Here's what the project is about. In the world of databases, you may know that there's a bit of an annoying thing, which is that to connect to most SQL databases, you have to use a TCP connection, right? So like you have to have this like driver thing, and there's a special bespoke protocol, and you have to like download a bunch of crap, and it's annoying, right? It's like, it isn't very like new school, you know what I mean? And here's what do I mean by new school? Well, what I mean is that new school things have APIs that are like standard. You know, they're made of REST or they're made of GraphQL. SQL databases typically don't have REST APIs. In fact, I don't know if any SQL database has a REST API that's like native to it. I think one thing that's cool about FaunaDB, I don't know if you guys know FaunaDB, but FaunaDB actually does have a native API that doesn't just give you access to like a database handle. It actually is an API to the database itself, which I think is sweet. That's something that they did that I think is quite smart. But for example, if I go to click GraphQL in their example here, you can actually literally send a regular API request to their site or whatever and get back your data, which is, it sounds simple, but it's kind of next level, because most of the time when you build an application on top of a database, you have this like middleware layer thing that like translates the API request into a database request. You know, you don't really do that database request directly through the internet. Whereas this Fauna thing actually does have such a capability. And we think that just as a trend, more people want to do serverless, more people want to do edge compute, more people want to do stuff involving pushing processing towards the user, right? People want to go global with their applications. People want to do some of this stuff that kind of is easier to do with technologies like serverless functions or functions as a service, backend as a service kind of thing, where it's kind of nice to have an API to talk to and not some kind of weird driver thing. So one thing that's kind of neat is there's a project called Postgres. So conceptually treating the database like a headless CMS, which basically gives you an API over your models. This is new to me. Yes, exactly. So Fauna does let you have exactly what you're saying, right? It's pretty neat. You know, native GraphQL on a database is something that's pretty badass, I have to say. Pretty badass. So what Postgres does, there's a few projects. There's a few interesting projects of this nature. There's something called Prisma. So Prisma is a thing that is similar to Fauna's API, it's very neat, and I'm interested in it. And I think the idea of Prisma is basically that it gives you a GraphQL-like front end to any database. So they kind of have a back-end database selection that you can pick that they will translate your GraphQL calls to. And then you can do the same thing where you tell your serverless functions to just talk to this Prisma API thing, which then does that translation for you, right? So it, again, is sort of skipping some of this painful middleware creation or painful lack of, ability to use a sort of SQL driver from your serverless function, ultimately, is what it's about. So Prisma's cool. Supporting Prisma would be another good thing to do for any database, including CockroachDB, but any database would be nice as well. So there's another project called Hasura, which is another similar thing. Hasura is a GraphQL front end for databases. Also has several backends. similar concept. So these things are kind of breaking out everywhere. You know, it's a popular concept right now. Postgres is nice because it's a sort of maybe an earlier version of some of these ideas, that instead of using GraphQL, which is a little bit newer, it's using REST, regular old REST. And one of my colleagues, Nathan, was working on adding, so Postgres, it uses quite a lot of these kind of complicated Postgres features that we don't always support inside of CockroachDB. So he was sort of working on this big checklist, bunch of stuff to check off here. What are these little weird features that Postgres has that CockroachDB doesn't, that we can add so that Postgres with a T will be supported in CockroachDB, right? So that's kind of what, I've got a couple of these mini projects to work on the stream today. It's funny though, because if you look at some of these, they're not like necessarily rocket science features. They're kind of like these little baby compatibility things, like make sure that your array ag function can take records, or make sure that you can use these like customized session options, which didn't even exist. So apparently in Postgres, you can actually set arbitrary key value pairs in your session, which is kind of insane. So it kind of lets applications just set arbitrary state just for a session, which is neat. We don't support this. Didn't know we needed to. Didn't know anybody used this, but apparently they do. That's the thing. Anytime that you have any neat little feature in the thing that you're building, right? Somebody's going to use it and depend on it. So that's always a fun thing. So what's the problem statement for these solutions? The problem statement is ultimately, I am a developer who wants to use serverless functions to write my application. If you're familiar with serverless functions, that's something like, you know, Amazon AWS Lambda or Google Cloud Run, or I think Netlify has Netlify functions or something like that. And right there, these like little snippets written in, you know, JavaScript or Go or whatever that get invoked via APIs. One thing that's kind of weird about serverless functions is that they want to be spun up and spun down very quickly and be stateless, right? And have no, it's really about quickness of spinning up and spinning down and about statelessness. So one thing that is tough if you want to be a database talker to as a serverless function, you've got to still make that cursor. You know, if you're a SQL user, you know, you have to sort of establish this heavyweight connection and this heavyweight cursor and kind of like go do something. So the reason that people like this GraphQL or REST stuff instead of just using the raw cursor is that it's stateless, right? You don't need to keep around this more heavy object and have a TCP connection and everything. It's just your sort of regular old API calls. So that's the idea, you guys. That's the problem statement. What do you think? Does it make sense? Time Frog, did I convince you? Also, hello, Lithium. Good to see you. How's it going? It's been a little bit. Welcome back. I feel like this music is too intense. I'm chilling it out. We're going back to lo-fi, non-copyright hip-hop beats to game and stream to relax a little bit. High energy intro, but can't stay on the high energy forever. Okay. So, the first guy that I wanted to work on today was going to be something called a bug. So let me show you what I mean by this bug. Basically, there's a little bit of an issue with, we have something called JSON ag. Let me make a quick example here. Say I have a table A, it's got an integer in it and a JSON in it. And I wanted to, actually, wait a minute. I don't need a JSON. Let me drop this thing again. I'll make another table, create table A, and primary key be int. So one thing that's weird about SQL is that you can do something like this. Normally people are expecting to say select star from A, right? And you get the values back. But you can also do something kind of wacky, which is that you can select the table name. Wait a minute. Except in this case, we've got a column and a table name that's got the same thing. So let's fix that. Let's make the columns called B and C so we don't have that conflict. So here's a table called A with columns B and C. I'm going to insert into A values 1, 2. And so normally I can go like this. It gives me B and C. I can also say select A from A, and it gives me back this kind of weird thing, which is a tuple. It's a record type that is composite, that contains both of the types of the columns in the table. It's a little odd. You can also do something which is also weird, which is say a.star from a, and that'll re-expand everything back into the component parts. It's kind of weird, just a feature that exists, but that's not really the point. What I wanted to show is that I can actually say something called select JSON ag of a from a, and it does something pretty insane, which is that it kind of blows up the input tuples into JSON in an array order kind of thing. This is very weird. Very weird. What it's doing is saying, and in fact, let me add another example here. So I'll say insert into a values 2 and 3 to get another record in there. Now, if I say select JSON ag of a from a again, then what I get is an array of JSON with 1 record per row. And you'll also notice that the keys in the JSON objects are equal to the key of the column name, or equal to the name of the column that is getting aggregated. So, you know, it's a little weird, but it's kind of handy for people's use cases, it turns out. People like to use this JSON ag thing. So, all good and fine, but there's a bug. There's a bug. This has always freaked me out. What's up, null bitmap? Yes, it freaks me out too. It's pretty freaky, I think. It feels dirty. Deeply dirty. Deeply dirty. In fact, there's something that I want to show off on a little quick tangent that's much dirtier than this. In fact, it's so dirty that I don't even know what to say about it, but let me show you something super weird. It's called select JSON populate record of one comma 2 as a b. No, wait a minute. Do I need to put this whole thing in parentheses with a select? Does this work? Do I need to put this in parentheses? Okay, this is the spookiest thing of all spooks. It's called take a tuple with names and then parse the JSON on the right hand and insert the names of each of the objects things into the tuple based on the tuples field names or whatever. It's disturbing, deeply disturbing. But hey, people like it. People want to use it. This is in fact one of the things that we needed to do for this bigger issue here. And it gets even weirder, and we're going to get to some of the weirdness later on the stream, but one of the very weirdest things that people like to do, nobody likes to do this select one as whatever syntax in the beginning. What they really like to do is say this, cast null to the name of a table. And what that does, which it's not going to work in this demo because we don't have this patch installed, is that it takes the tuple type of this table, like we were looking at over here, and it gives you an empty tuple to populate with the stuff on the right hand side. So people get really freaky with JSON. That's kind of the summary of all of this stuff. People love some freaky JSON stuff, and it is terrible, I would say. It's not necessarily terrible, but it's definitely paradigm breaking. It doesn't feel like SQL. This is like a little sub language. Anyway, so what am I talking about though? There's a bug in JSON ag that I want to get to. And it only comes up in some kind of weird circumstances. So let me create the circumstance for us. We need a demo that has more than one node. So as soon as I say that, you have to be saying to yourself, oh crap, why is this a thing? We need to make a table like we did before. we need to insert some data into it like we did before. We need to alter table A split at, we need to like distribute the table a little bit. And then we've got to do the same query again and make sure that the range that we're reading from is not on the local node, which it is right now. So I've got to say alter table A scatter and then hope that I get a different plan, which this looks like it is. So here's what I'm getting now, is that I'm getting a plan in which I'm sending the rendering of these tuples out to all of the nodes in the cluster, and I'm pulling them back in to my main node, and I'm aggregating them together with this weird JSON ag thing. And so unfortunately what I get though is something gross. Ignore this debug printout. This is something I was just poking at, but you can see that there's something wrong here, which is that we're no longer printing the right labels in these JSONs. We're printing some F1, F2 business, which I think basically means that we've forgotten the record labels somewhere. Record label, by the way, holy crap, that's kind of weird. That's a mixed, that means something else in normal English. But anyway, we've forgotten the record labels, field labels, record field labels, somewhere along this distributed computation, which is terrible, really, because remember, you guys, what we want is we want it to look like this. We want it to look like we know the name B, we know the name C, because this is coming from a table with B and C as the column names. Okay, so why is that happening is a question that I don't yet know the answer to, frankly. I don't yet know the answer to. I think, okay, so let me give you a quick rundown of what I'm looking at. I am expecting that there's one of a couple of different reasons for this. One is that when you send a datum, which is how we represent data in memory sometimes, they don't include their own tuple labels some of the time. And they definitely don't include them when they're getting sent over the wire. They kind of include them in memory. So I'll show you what the tuple representation looks like in memory. It looks like this. It's got a datums, and it's got whether it's sorted or not, and it's got a type, right? And this type is what contains the actual field labels. So if this thing is empty, then we're going to get this F1 to F2 business, which is definitely happening somewhere. The question is sort of where. When we send this over the network, though, we definitely are not going to include this type. And I haven't actually verified that yet, but let me verify that. Encode tuple? Encode tuple? There's got to be something like this that exists, right? Encode tuple. So this is what we do when we're encoding a tuple value. And what we do is we completely ignore the type. We simply iterate through the values and we encode them into a byte slice, and then we ignore the labels. So that's definitely problematic from one perspective. But on the other hand, I happen to know that there's something else that we do that's kind of sophisticated. When we set up this computation here, we don't just send the untyped datums and like hope. Basically, each of these little boxes, they actually have an instantiated set of types that they're expecting from their inputs. And so theoretically, this guy, the aggregator, which is the thing that takes JSON ag items and aggregates them together, should actually have the proper type information, which is like AKA the tuple with its fields. And I actually think that I did verify this by saying I have to turn this off, and then I have to, if I run this guy with this debug print that I had in front of me over here where it says found input types. What's interesting is that I actually do get found input types tuple int is B int is C, which is correct. What's up, Lieutenant Junior? Also, hello, Semson Mizin. How is it going? Right? So at this point, I actually do have the right types. And I think that I actually use these things later for decoding the values. So I was thinking that this would sort of save us, but it actually might not. I don't know. I don't know. I think next thing I want to maybe do is say, maybe I want to say something like, what do I want to say? I basically just want to figure out what type we have when we're like staring at this thing. And yeah, I mean, it really does feel like we would have the right thing. Although I do see kind of an error here, which is that over here, when we use this resolve type stuff, this is actually using the dynamic types of the data. And we definitely have the wrong dynamic type at this stage. So I'm wondering if maybe this is kind of the issue here. Why don't we print out, but I don't think we're actually going into this, we're not like in this case, so I don't think it really matters. Tricky, tricky, tricky. Here's the other thing that's confusing that I don't actually understand at all. Like if we go to the implementation of our JSON aggregate built-in, right? We're the whole point of what we're trying is looking at JSON ag, right? So what does JSON ag even do? If I go to this JSON aggregate thing, which I think is what, that is what JSON ag resolves to, right? Yeah, here's JSON ag. Aggregates values as a JSON or JSONB array. And it takes anything and it gives you back JSON. And so if I go over here into new JSON aggregate, what do I even have inside of it? I have, it's kind of weird because like, why does this thing expect this thing to be a JSON already? I don't exactly understand that. That's what I was confused about. Because I was expecting, look, I mean, we're not passing JSON into this thing. We're passing like a tuple. And so why does this thing get JSON in the first place? We could try something like figuring out what we're getting here. JSON ag add, and then just pass in the name of the datum that we're getting sent. That could be interesting. Accumulates the transformed JSON into the JSON array, but like who's doing the transformation? That's my question. There's got to be somebody else doing that. And I'm missing where that's happening. What is this add thing? Yeah, this just implements aggregate func, right? Who is doing the thing? Who is doing the thing? That's what I don't get. That's what I don't get. I don't get it even a little bit, frankly. Datum.resolve type, I guess. I don't know. Let's just, we'll see what happens when we print this stuff out, at least. I think I'm missing like a crucial step somewhere in here. Isn't debugging fun, you guys, by the way? I gotta love debugging. You just kind of poke around trying to figure out what in the heck is going on. And I truly have no idea what's going on. But it's kind of fun, you know? It's like, it's kind of fun not knowing. The not knowingness is always a good time. So I just need to figure out how we're transforming the JSON, or these tuples before they get to JSON ag. Maybe JSON ag has like a special case somewhere in some other code. Could that be the case? Doesn't really seem like it, but suppose it's possible. Like who is doing the transformation? Who's doing that? Please tell me. Please somebody tell me. So okay, so that's actually really weird. It is getting a tuple, but, oh, so maybe this tree as JSON thing. Oh, this isn't expecting a JSON. Oh, okay. Oh, you know, it's actually interesting. This will actually tell me so much more. So let me go back and do my scatter. and well, we'll do our altered table split. We'll do our scatter. We'll do our select. And check this out. So in the distributed case where we have the bug and we're getting back f1, f2, what we have is tuple int, right? Which is not the right type, of course. So okay, we understand something, which is that whatever we're getting passed here is of the wrong type. Fine. Fine. So we have to make sure that this is the right type, ultimately. That's really what it comes down to. And we have to do it in two places. We have to do it in vectorize and non-vectorize. We're going to start with non-vectorize because it's easier. And what's kind of wacky, though, is look, we get this found input types of the good type. And then at some point in between here and here, we lose that dynamic type information. So we've got to find a way to get that back, right? We've definitely got a way to do that. Got to find a way to do that. So here's our first arg, and I think this is probably where it's happening. Accumulate row into bucket. It's got a first arg, and we grab it using this method. And we do it actually using something interesting, which is that we actually take out the datum from the Cth spot and row after decoding it using input types, which is correct. I think this input types thing is actually correct, but maybe what's happening is that somebody has already ensured decoded this thing with the wrong type. I feel like that might be what's happening here. So let's print out ag decoding row, or val, I guess, and we'll print out row of C. And then over here, we'll also print out ag.input types of C just to make sure that we do in fact have the correct type information at this point, which I think we do, but just to verify. Just to verify. So let's try again. We're gonna do our create, we're gonna do our insert, we're gonna do our split. Whoops, let's not do that. We're gonna do our scatter, we're gonna do our select. Okay. And we also have to turn off vectorized. So here's what we get. So this is very interesting. Check it out. We have some good stuff, which is that we've got a datum that hasn't yet been decoded, which is what we want, and we have the correct type information. So that is very weird. And I think that maybe it's a bug in this ensure decoded routine then. It's got to be something like that, right? So let's check out decode table value. It takes this type. We know this type is the right type. Decode on tag datum. Go down to tuple family. Decode tuple, takes the type, tup type. And we just ignore the type. So this is the issue right here. So this is it's not so bad. It's as easily solvable, and it just took a little bit of staring. Oh, you know, it's actually really funny is that this, our datum alloc is missing a method as well. It's missing a way to get a new tuple with a specific type. And what's also really funny is this is the only place in the entire code base that we have this method used. So we can just edit it completely and add another, wait a minute. I think what we should do is two things. One is that this needs to have the type, right? And we have to construct it in a different way. We have to say tree dot new d tuple. We've got to pass in the tuple type. And then we've got to pass in this new datum's business, except Okay, I have a better idea. Here's what we're gonna do. We're gonna say new D tuple with len. We're gonna pass in tuple type. We're gonna pass in 0. And then we can do better. We can do better. We're gonna go like this. Then we're gonna say result dot d is equal to a dot new datums like this. And then we're gonna do all the decoding like this. And then we're going to actually allocate the D tuple from this allocator machine. And we're gonna be passing in result. So I see. The reason that they were messing around with this stuff is that they wanted to avoid this initial allocation. I don't think that this really matters at all, TBH, but I get the sentiment. I do get the sentiment. But truthfully, I think that if we do it like this, this isn't even going to escape, because it can tell that we never like leave this reference and stick it anywhere else weird. So I think we're good to go. Maybe. Especially if we go like this. Okay. This is good. Okay, I think this is gonna probably fix the bug. Let's check it out. See if it fixes anything. I think it's gonna fix it, but we'll find out. Should we do a prediction? Okay, we're gonna do a prediction. I love doing a prediction. Start prediction. Did the bug fix the bug? Possible outcomes, yes or no. Submission period, I'm gonna make this a 1-minute submission, all right? You have 1 minute, bet your channel points, okay? So the way this works is that you've got channel points from watching the channel, right? And you can make a bet. And you can bet yes if you think that this bug fix that I just did is gonna fix the bug. And you can bet no if you think it won't fix it. And then if you get it right, you get the channel points from the people who got it wrong, all right? So everybody vote. I need like a little voting song. I want everybody to spend all their channel points on this, okay? And let me tell you, there's a lot of good things that you can do with large data bank channel points. Lots of things. You can use them for clout. You can use them for more clout. Oh, hell yeah. Who bet 10,000 points? This is what I'm talking about. I like that quite a bit. I like that quite a bit. Let's go. Let's go, dude. A true believer. A true believer. Man. A really good way of promoting degenerate gambling behavior by rolling the dice on programming bug fixes, right, guys? I hope that you're not going to be insolvent after this. Kosaki, what's up? 100 points? Okay, let's go. So we compiled. We compiled. We're going to create our table. We're going to insert our values. We're going to split at. We're going to scatter. First, let's do an explain to SQL just to make sure that we're actually getting the... Okay, we're not yet getting the good plan, I don't think, here. Maybe we need to do another scatter. Okay, I think this is a fair check. We're gonna set this SQL to be off, or vectorize to be off, right? And I think we have a debug message that will be printed if, in fact, the bug would have been triggered. So let's see what happens. I think it worked. Found input types, tuple, ag decoding val, tuple, JSON ag add, tuple. So this is a new thing. We're propagating the type, and look what happens. Look what happens. You get the good stuff. Let's actually also check. Okay, so I'm gonna let the yeses win here. The bug fixes did fix the bug. So how do I do this? Prediction. Choose outcome. The answer is yes. Whoever bet that 8%, I'm sorry. You have lost your channel points. Thanks for participating in this really wonderful and constructive game, everybody. Okay, so let's also check to see if it fixed it with vectorize equals on. I think it might, but I'm not sure. The answer is yes. Okay, very cool. Very cool stuff. So let's actually just go ahead and package this up. It's a very little simple fix. Maybe I should write a test for it though. Should probably write a test for it. How would I test this? How would I test this exactly? Value encoding test. Okay, so maybe I wrote like a really janky test over here, but let's just write a quick little test. So we're gonna say func test decode tuple value with type. Flintstone, thank you for making the bet fun. You'll get it next time. You'll get it next time. I think most of the time, I think this is rare. I feel like a lot of the times when I think a bug fix was gonna succeed, it probably would not succeed. I think it's hard to predict whether a bug fix is correct or not before you actually test it, at least in my experience. So we're gonna do a test, decode tuple value with type. And it's just gonna be a very simple unit test here that runs one of these things. So let's see, how are we gonna do? We have to go like this. Why is this printing? I'm gonna delete that while I'm at it. Okay, so we're gonna make our buffer nil. We're gonna make no column ID. Our datum is going to be tree.newDtuple. We're gonna pass in a tuple type. So we're gonna say types.make labeled tuple types.t types.int types.string, let's say, and the labels are going to be string a b, and actually we don't need the with len. We'll just construct it directly. We're going to put 1 and then foo, like so. Of course, these have got to be datum values, so we'll say tree.newDint or whatever. Mateus, what's up? Tree.newDstring. Okay, so we have our datum. Our scratch is just going to be nil, I guess. Go like this. And we're going to redecode. So this test ensures that decoding a tuple value with a specific labeled tuple type preserves the labels. Oh, wait a minute. This is actually in the wrong package, isn't it? I want... something that is, I guess it's in this row enc package. Decode table value. Value encoding test. Okay, so there's a different... Wait, what? Okay, I'm moving it to another file. moving it to another file. Don't get distracted. Don't get distracted. This is the file. We're going to do decode table value. We're going to pass in our datum alloc. We're going to pass in our type. Let's extract this guy into a tuple type. We're going to pass in our tuple type like so. And our byte slice is going to be our buff. Right? What's wrong with this? Assignment count mismatch. I need decoded. Oh, right. Decoded, ignore, error. What is this middle argument anyway? Middle argument is the type. No. The middle argument is the remaining bytes, which we don't care about. So decoded, var decoded, datum. Will fail if we found an error. And then we're going to say require.equal t decoded. I guess we should extract. Yeah, we already have that over here. Datum. Right. And I think that this will basically, what does this do? Is this equality as opposed to memory addresses? Does this work? I don't know. Let's run this test. So we're going to say make test package equals package SQL row enc tests equals test decode tuple. Okay. All right. We read a test. Feeling productive. Feeling super productive. It's a little weird that this didn't get tested because we do already have a bunch of randomized tests for this kind of thing. But maybe it's just a bit unlikely that maybe, you know what it is that our random datum generator doesn't ever create tuple types. That's got to be what it is here. It's got to be what it is here. Right? Code table value D gen datum. Oh, and we only check the dynamic type. Yeah, so this is a little weird. So this is basically doing round tripping, but it doesn't actually use the original type that we used to generate the datum from, which is definitely weird. Definitely weird. And I'm not sure. This does actually make a tuple, but it doesn't use labels. It doesn't use labels. We should fix that. We should fix it. So this does actually work, which is great. But we should probably enhance all of these things to be less lame. Like we should make labeled tuple. I'm a little afraid if I do this, it's gonna like break all sorts of other stuff though. So let me actually just make a commit out of the stuff that I have so far. And we can add this other things later. So we'll do git add -p, which we all love, to figure out just exactly what we want to keep. So we might as well remove these formats while we're here. It doesn't matter.
I have to narrow down the search.
We're not gonna add this. We're not gonna add this. We will add this. We will add this. We won't add this. We won't add this. We won't add this. We won't add this. So most of it was just prints. The whole change itself was literally just like a couple of lines. This is basically the lines that we changed to fix the test. So very cool, or fix the behavior rather. So let's go ahead and make a commit. We're gonna say SQL preserve tuple types when decoding. Did I already see prest, another REST API to Postgres? Oh my gosh, no, I did not. This seems really cool. I wanna try this. Look at all these contributors, amazing. Wow, even Dependabot helped. Thanks, Dependabot. Wow. It's new. Goodness. It's Haskell. Oh, Postgres is Haskell. I see. This is the non-Haskell one. Ah. Maybe I should play with this. Maybe I should play with this. Okay. Previously, when decoding, tuple types from table from sent, encoding tuples sent across the wire in dist SQL. Tuple labels were not preserved due to an oversight. This oversight is now corrected, and tuple labels are once again properly preserved in all queries. Release note, bug fix. Some queries, how do we say this? Fix a bug preventing tuple type labels from being properly preventing tuple type labels from being propagated across queries when run under dist SQL. Okay. So let's go ahead and get rid of some of these debug prints here. In fact, we can just delete the rest of these changes, get CO 1 through 3. We're gonna go ahead and check out our master branch. We're gonna rebase. We're gonna delete whatever this stuff is because apparently it got deleted or something. We're gonna make a new branch called fix tuple label erasure. Always cool to use the word erasure when talking about forgetting about types, right? Just to sound a little bit extra fancy. Get cherry pick JSON to record. Okay, so we're gonna go ahead and make a pull request from this. Do I need to change any? I think I might need to run make basil generate since we did change some imports. So we'll do that real quick. And then next up, we can get back to the bigger project that we started last time, which was about these table tuple types. Table tuple types. We need to look into whatever's going on here. What's going on here? Cannot query Bazel test got error exit status 7. Maybe I introduced some kind of uncompilable state due to changing the branch or something. Or I somehow broke. I think I can run this to figure out exactly what went wrong. Okay, so that worked fine. We're gonna run this thing to see what didn't compile properly. Okay, so it says, cannot find a oh God. It's something to do with the front end. Please no. Let's just go ahead and pretend this never happened. Or maybe, do I have to just remove this or something? No. What? Could not find. Yeah. I'm just gonna go ahead and ignore that and fix it by just manually editing the build.bazel here. And I don't even need to do that. Okay, whatever. We're making a pull request. Let's just ignore that that ever happened. Nobody has to know. It's just between you and me. Okay. So then we can say fixes tuple label. How am I gonna find this issue here? So if I go to issues, this guy. Okay, so we're gonna say fixes this. We're gonna say create a pull request, and we're gonna, who are we gonna send this thing to? Who is? Okay, we'll try that. We'll try that. I also, yeah, kind of want to figure out if there's anything actually wrong with this guy. So this is another related, I was showing this thing off earlier. This is another related PR. It seems to be failing some tests, so I just want to make sure that there's nothing weird going on there. Let's recheck out JSON to record. We can get rid of this thing since we moved it to another branch. And the test that claimed to fail was called test geobuiltins point empty args. So we're going to run that real quick. Make test package equals package SQL sem builtins test equals test geo builtins point empty args. How's everybody's week, by the way? Anything exciting happen to you? Unexciting, good, bad? Any plans for the weekend? What's happening with everybody? Getting ready for vacay. Vacay. So we do have this error. That's good. Where are you going for vacation? Oh, this is failing because minimum bounding radius. Namibia, my goodness. That's an adventure. Kayaked up to North Brother Island. That's an epic journey. People are very much into the Brother Island. That's like a New York mythical place. The only commit that I did into the code base this week was a copy of another colleague's commit that we cannot submit because he's on paternity. So you're saying that there's a policy about that and you had to spend time copying it? That is, or maybe, oh, maybe the code was lost because he went away and you had to like redo it basically. That's annoying. That is annoying. How long are you going to be in Namibia for? Two weeks. It's a good amount of time. I haven't taken a 2-weeker since before COVID. I think I'm going to take one this winter. I'm going to go skiing. Go to Colorado. That's the plan. He's enjoying that fatherhood. Exactly. That makes sense. Well, look at it this way, Jack. You did him a favor. You did the guy a favor. You're helping the world be a good place, right? So I think we just need to say, what is the point of this? Tests point empty arguments do not cause panics. Over 2 years for you. You deserve it. You deserve it. Okay, so just a little fix up of something. Basically, I slightly refactored the way that these functions and generators work, so I've got to make a little change, but it's no big deal. Oakley doke. So let's try now. I think this should fix things, hopefully. Then we can maybe get back to the other project. Okay, very good. Add this, amend the commit, push it up. Okay, so the next thing to look at, you guys, it's quite exciting. I did mention it a little bit earlier, and it is, let's also just thanks for reporting this. It was a small bug. Something that somehow never got noticed in the tuple type deserialization routine. Okay. So, right, the next thing to look at is this crazy thing called create named composite type per table. So what is this about? Let me show you the branch that I've got for it. So if I check out implicit record types, let's rebase this thing. Let's go ahead and make build short. So the idea of this implicit record type business is what? Basically, the idea is that I kind of mentioned it earlier, right? Every table, it's got the columns that it has inside of it, right? And it kind of has an implicit type already, right? So if I do that thing where I say, I'll show you, create table A int, B int. If I do that thing where I say, select A from A, whoops, I keep doing this thing. I have to name the columns differently from the name of the way that the table is named, or else the trick doesn't work. So I have to go like this. So what this gives me back is a tuple. And the tuple actually has the values of each row, and it also has the labels of each of the columns, right? So if I say select a.star from A, it gets popped back out into these columns. And in fact, I can also do weird stuff like select a.b from A, and it gives me back the B column from this like weird tuple thing, which is, it's a little weird. It's a little freaky and disturbing, but it just is what it is. And the truth though is that like, if I were to get the PG type of A, it gives me back just this like record type thing. And really what's kind of interesting is that in Postgres, they don't just give back this value as an anonymous record type. They actually give it back as a tuple that's hard coded, so to speak. It's sort of like a customized tuple whose name is the table. So what that actually allows you to do is you can say something like select 1, 2, and you can cast it to A, which is very bizarre if you think about it, because A is a table, but in Postgres, it's both a table and a type. And I can, if I cast this thing to A, then I can in fact do that same thing that I did with the select from, where I can say 1, 2, cast it to A, then I can say .b on it, and give me back the B attribute, or .c gives me back the C attribute, .star gives me back both of them. Whereas of course, if I didn't do the casting, it gives me these anonymous columns back. You see the difference here? We're propagating the column information from the type into the tuple itself. And so this doesn't exist in CockroachDB today. This is only existing in the patch that I just have checked out on my computer. And I want to improve it because there's some issues with it. I'll show you, I sort of sent this thing up as a pull request and I got some good feedback, and I want to improve the PR to address the feedback. That's kind of the plan here. And basically the feedback. So the thing that I'm doing is a little bit jank. The thing that I'm doing that's a little bit jank, probably more than a little bit, is that I am synthesizing a type descriptor. So in Cockroach, right, the way everything works that's persistent, every like schema element, so a type or a table or a view, column, etc., it has something called a descriptor associated with it. And what I'm actually doing is synthesizing this descriptor in a kind of gross way when somebody tries to resolve a name that is a table as a type. So it's kind of a hack, because the truth is that we're not persisting this table in the like descriptors table or anything like that as a type or as anything at all. We're just sort of pulling it out from thin air. If somebody tries to resolve a type that has an existing table with the same name, right? Does that make sense? So I see A, I can see it's a table and not a type. So what I do is, instead of just, throwing an error, I actually synthesize a special type descriptor that is this table's record type. And so the feedback that I got that I think is pretty good is that what I'm doing right now is I'm actually pretending that I have a real descriptor here, which is gross. And the better thing to be doing would be to be giving back a new implementation of this interface here. So what's going on is that I've got this big old interface called type descriptor. And instead of giving back an immutable type descriptor or a mutable type descriptor, I actually want to give back something completely fresh called a virtual type descriptor or something like that, which so why do I want to do that? I guess the point is basically that it's just going to be messy if the like physical desc PB type descriptor, which is a protobuf thing, gets like accidentally escapes, because then people are going to be confused. Like the code will be like, why does this exist? And it's not on the disk, or it's not anywhere. Like, what is even going on? So I kind of think that like the point of this is to just make sure that the code that touches this stuff is aware that it might be getting something that isn't persistent, and therefore doesn't need to be like considered when persisting things, or something like that. Something like that. The only thing that's a little bit weird is like, look how, so this interface is really huge, obviously, which is fine. one thing that's very interesting is that you can actually ask this interface to give you back the underlying deskpb.type descriptor, which like we would never actually want to do in this case. And I guess that's fine. What we would do is we would make this thing panic and then like make sure that everywhere where we might be checking this thing, we just like don't do it because we know that we don't have to, right? We know it's virtual. We know it can be ignored. It doesn't need to be persisted or serialized. Tricky. It's a bit tricky. I'm just thinking about it a little bit. Okay, we can figure something out. We can do it. We can do it. Let's just start playing with this and we'll see what happens. So the first thing that we have to do is notice that sometimes people want a mutable one of these things and some people want an immutable one of these things. The truth is that nobody should ever be able to get a mutable one of these things. It's like, we cannot mutate this thing. It's immutable, it's virtual, it doesn't exist. So I think the first thing that we should do is just delete this method altogether and force the other guys to become the new thing that we're gonna create, right? So, no, we don't need to delete it yet. I think what we wanna do is just make a new thing called create virtual record type from table desk, right? This is specifically what we wanna do. Create virtual record type from table desk. So it's going to take in a descriptor catalog table descriptor. And it's going to give back catalog.type descriptor. The only difference is that it's actually going to give back a new type of type descriptor, which you haven't yet defined. And I guess we could just define it here, maybe. Are the other ones defined here? Kind of seems like it, right? We'll just go down here and we'll say type virtual table record type or something, and it's going to be a struct, and we're going to make a quick comment here that we're going to say virtual table record type is an implementation of catalog.type descriptor that represents a record type for a particular table, meaning the composite type that contains in order all of the visible columns for the table. Okay, simple as pie. And we're going to want to actually implement this giant mega interface, which is going to be really quite fun. And that mega interface is called type descriptor. So we can just tell Golang to go wild here, and it's going to make me about 1 bajillion methods to fill out, which I'm not really looking forward to. Well, it's not that bad. Is it that bad? It's a little bad. So one thing that we could do that I don't think we should do, but we could, is say desk catalog.table descriptor, right? And we could have all of these calls delegate to whatever table descriptor we passed it. But this feels a bit sketchy, I would say, because I think what we would prefer to do is not have to keep this guy resident in memory. Like, what if it goes away? I don't know. It just feels wrong. So I think what we really want to do is flatten and like push all of the stuff that we need from the table descriptor at construction time into sort of member variables of this guy. Yeah. So let's try it out. We're gonna say, I think, we know that we're gonna have a name. I can't decide. Let's actually just start by having it delegate, and we can always split it out later. Desk is the table descriptor that it looks like a keyword. It's just short for descriptor. The table descriptor that this record type this virtual record type is created from. You do Jordan. Does it make more sense to eagerly pop out all the fields that we care about from this backing table descriptor into the struct rather than have all of the methods delegate?
The data bank's too big. I have to narrow down the
Okay, so
search.
get name,
Are you gonna
return v dot desk dot get name. Parent ID. So what is parent ID supposed to do again? Parent ID says I think we can just delegate these ones as well. So get parent ID, I think it's basically giving you back the ID of the owning database or something. Parent ID. Why does that keep happening? So the ID is going to be, this is the thing that's a bit confusing. For now, we're just going to return the backing ID as well. That's what we did in our prototype over here. As you can see, the ID of the virtual table descriptor is a type ID, not the table. Well, this comment is no longer accurate, so we'll just delete it. We'll also just delete this. But let's go ahead and figure out whether this makes any sense. So yeah, you're right. I could conceivably just embed it. I could conceivably just embed it, but I think, well, maybe I should just embed it. I think it's confusing to embed it though, because like there's a lot of these ones that like we might want to be different. And if you embed them, you don't actually get to see all the implementations. So I think for now I'm gonna avoid doing that, but it's kind of a fair, although now that I'm doing this, maybe you're kind of right. You know, hold on a minute. I just realized something. I just had a flash realization of something that I need to fix in this other PR. Let me just quickly, very quickly go over here and make sure that I said that I responded to some comment that I didn't actually respond to, which I'm feeling guilty about. So let me just go ahead and fix that. Resolve type implements the value generator interface, I need to say. Quick tangent. Sorry about this. Sorry about this. It is part of the
Because space never ever ends.
Okay. Okay, sorry about that. Back to reality. Back to reality. Thinking about embedding. Do we want to just... I think that we definitely don't want to just embed. I think it's a bad idea. So I'm just gonna go ahead and do all this pain. I'm just gonna put a little to-do. To-do Jordan. If we keep the embedded catalog dot table descriptor, how about that rain? Is it raining? It's not raining. It's not yet raining where I'm at. Is it raining? Will it be raining soon? If we keep this embedded table descriptor, do we want to just use Go embedding to avoid writing all of these delegate calls? For now, I like keeping them explicit since it forces us to think about, yes, I still live in Jordan's secret neighborhood. Think about the implementations separately from the table descriptor itself.
The data bank's too big. I have to narrow down the search. How are you going to do that? By guessing.
I still have a dream. It is a dream deeply rooted in the American
This is
dream.
Martin Luther King.
I have a dream.
Okay, yeah, it's kind of weird, a little awkward. Okay. Return v.desk.get modification time. You gotta remember to put desk in here, else it just loops, right? It's key. This one likes to... guess the line is too long. Okay, so whoops, get rid of this. Why? I guess we should think carefully. Draining names, I don't think we want to implement. It's annoying that these don't have comments. It's very annoying. Don't quite get why they're not commented, but I don't really know what this means, to be honest. I guess maybe we could pull the comments up from, well, these don't have them either. Draining names, a list of draining names. The draining name entries are drained from the cluster-wide name caches by incrementing the version for this descriptor. The field is then cleared in the version of the I really have no clue whether we should be implementing get draining names like this or not. A drainage clip, from there will be blood.
You're not the chosen brother, Eli. Just like, listen.
I mean, I know this clip. Does he ever say drainage? Oh yeah, drainage.
Drainage, Eli, drainage, Eli.
This would be good to include in some sort of documentation, wouldn't it be? It would be pretty good.
Drainage, Eli.
Drainage. I love that. What a good movie. I haven't seen that in an awful long time. But yeah, truthfully, I don't know. Truthfully, I don't have any clue I kind of think that we're going to return nothing here. But I don't know for sure, for certain. So okay, so we're going to write something like that. Modification time. Privileges is weird. I think for privileges, it's the same. I mean, well, not quite. I think what we want to do is like, we can never drop this thing. Well, I'm going to say to do Jordan. We can't drop tables. We can drop these virtual types. So is it weird to say that we have drop permission on this thing, even if we don't? But why don't we just say that we have, for now, return v.desk.getPrivileges, the same as normal. We need to investigate this further though. Like, let's say we're in Postgres. Avoid leaking our password.
I have to narrow down the search. How are you going to do that? By guessing.
Say we're in Postgres and we run.
God, it's been a long time since anybody asked me that. I'm great.
I want to read the like permission information on some of this stuff. List table view and sequence access permissions. It doesn't actually show anything about types, does it? You know what's also interesting is that it doesn't have any listings for these implicitly created types, even though they're in PG type, right? PG type has these special entries for A here. And these are not actually included anywhere else. Is there like a forget show? So like there's got to be some priv thing somewhere, right? Column privileges, data type privileges. Wait. Okay, I'm confused. You learn way too much about this Postgres internal stuff, to be honest, when you work on these things, but that's okay. Okay, so we got privileges. We do have some data type privileges, but they only live in information schema, which is really quite hilarious. Quite hilarious. Yes. What we have in information schema dot data type privileges, what lives in here anyway? A whole bunch of stuff, but what's interesting to me is that we don't actually seem to have entries for the implicitly created user-defined types of each table. Do we? We do have something called table though. So can I say where object schema is equal to public? What do we get? Ooh, we do get some entries for this stuff. That is interesting. But there's nothing about privilege here. So I actually am just confused, and I think I'm gonna stop investigating this. This doesn't seem so important to investigate. To be perfectly honest, it's just interesting. I'll probably have to do it later though. Okay, so descriptor type. We're gonna return v dot type descriptor type. Right? Is there such a thing? Catalog.type. Audit mode. What in God's name is audit mode? Audit mode is disabled all the time. All right. Public. Why isn't this working? So I think for this, we want to return v.desk.public. We want it to be public if the other thing is public. For adding, I mean, I don't think that these really matter. I think we should leave these as panic. For offline, I think we should... Well, or is it exactly the same as the table descriptor? I don't know. v.desk. Let's leave them to panic for now, because then we'll learn like where they're getting called from, if they are getting called, which would be interesting. Like they shouldn't really be getting called, I don't think, is the point. Get offline reason. Offline reason. Okay, so we're gonna delete all this stuff. Descriptor proto, we also want to panic because we don't have one of those. Descriptor proto. No descriptor proto for you. Get reference desk IDs. We're gonna, so here's something interesting, right? We're gonna want to return true if there are any user-defined types inside of the, so this is the same thing. We're gonna just return v.desk.get reference desk IDs. It's the same darn thing. Validate self. For now, we're just gonna return to Jordan. Let's validate this thing. Actually, no, I think we're good. Okay, so validate cross-rate references. It's the same thing. Validate TXN commit. I don't know what that's about at all. Pre-commit checks. Okay, I think for this, we're going to do nothing as well. Type desk, is this going to be a panic because we don't have such a type desk? We have no type desk. Hydrate type info with name. Hydrate type info with name. When is this called exactly? Oh, this is hydrating this type or something? What does this do? What does this normally do? Fills in user-defined type, metadata for a type, and also sets the name and the metadata to the pass-in name. Hydrating a type with an unqualified name. Okay, so I think what we can do is implement this guy just the same way it's implemented here, but without a bunch of this complexity. So we're just going to copy it for now and then delete a bunch of the extra extraneous stuff. So we're going to keep everything. We're going to keep everything. We're going to do this. The type meta version... I think we'll say desk.get version. Here we know that there's just one type, one kind of descriptor, and it's always going to be this alias type. So we're going to get rid of all this stuff. We're going to get rid of all this stuff because we know it's a tuple. And get rid of all this stuff as well. And we're just going to do this. We're going to return dir 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 dir. What's up? Dir 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 dir. Okay, so we hydrate our thing. Make our types T is gonna be, what is this gonna be? We did this earlier. Let's try to remember what we did earlier. I think we just want to return our, see with this, we actually do need to do a little bit of work here. And it's like this whole business. This whole business needs to happen. So I think what we want to do probably is populate this at creation time. And so we're actually going to have a types.t here as well. And that's what we're going to do over here. Y'all. Hey, yo. Yeah, so it's kind of a continuation of the thing we did last time, which was to create these weird we're gonna be adding these kind of funky table record tuple type things. I don't know if you were here last time, but we were working on this feature here where we can actually resolve a table name as a type, which is very odd, but you can say something like this: create table A int, B int, and you can say select 1, 2, and cast it to A, which is normally a table type, but here it's a tuple type, and this will give you the magic power is called, say, .a, and it gives you back. Yeah, it's just like some weird stuff, but we're kind of continuing to do this. We fixed some other thing, and yeah, we're pushing the ball forward on the old compatibility train. It's super weird, right? It's super weird. The true end goal is so you can do something like this, which is really extremely weird. Oh, this branch doesn't have this function, but what this does is you cast null to a table type, and that gives you back. It like lets the function know about the format of the tuple that you're trying to fill in, and then you can pass in an arbitrary JSON record, and what it'll do is it'll fill in each of the fields of the tuple with the corresponding named field in the JSON object. So this is the end goal, and this tool and a bunch of other things like to use this to do type safety checks for JSON to convert them back and forth from tables, JSON to tables to JSON. So that's why this thing is important, and that's why we're going through all these great trouble to make these weird type alias descriptors. It's pretty weird, but whatever. Whatevs. Okay, so here we're gonna return virtual table record type. The desk is going to be the desk, script door, and the type is going to be the type. It's sensible, but there's a long chain of crap to do before we can do it, which is sad for us. So here we're going to return v.type. No. Pending schema changes, this is always going to be false. ID closure. What is this for? What does this do? It says no documentation on the interface. Don't know why. That should be improved. Should be improved. Should definitely be improved. All type descriptor IDs that are referenced by this type descriptor. Okay, so for that. For this, what we kind of need to do is like, do we need to have pre-populated this thing or what? I think we've done this before. We just need to kind of translate it over. So we need to say for alt range v.type.tuple contents ret is equal to make map desk pb.id And we return ret nil. All right. Is compatible with. Now that's a fun one. I've never seen that before. Holy macaroni. Compatibility comparison unsupported for type. Okay, it looks like we could just do nothing here, I guess. I think this is the same thing. We just want to return an error for all of these. Basically an ORM in your database. So Postgres is a thing that kind of is an ORM-y simulation. It just presents a REST API that you can call that translates to database calls, and the REST API is based on the schema. So in a way, I would say yes, it's an ORM in your database, kind of ish, sort of. Yeah. Okay, so here's a bunch of weird stuff to implement that we definitely don't care about. So I wonder if we need to make a new kind here, because, or maybe we could just panic. I don't know. No kind for virtual table record types. I think we'll probably want to make a new kind here, but we'll see. All this stuff is irrelevant since we're not an enum. It's kind of weird. It kind of seems like we should have, I don't know, maybe made an enum thing, like a special enum interface, rather than having this big ol' set of interface methods that nobody's ever gonna ever use. But num referencing descriptors. This does seem like something we should probably know about, huh? Well, actually, I think we should panic on this one too, because we should never have to know. And it's the same with this one. Okay, so with that done, we can now go ahead and change these create mutable from table desks to, I think we can basically just say desk is equal to type desk dot create virtual blah 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 from table desk, and then delete these. And then we should knock out these ones as well. So we'll say return create virtual record type from table desk of T. This thing is now deletable. And likewise for this guy. And this thing is now also deletable. Okay, so now that that's done, we get to see what crashes and burns because it's going to be a whole lot. And while this compiles, I'm going to run to the bathroom. I will be right back. Hey, I'm back. I'm back. Okay, so we were gonna look at what goes terribly wrong, and it's gonna be quite a lot. So let's see what happens when I say create table A, and then I cast something to A. It's gonna like panic or explode or something terrible. I guarantee it. Okay, it didn't. What? That's severely shocking. It's shocking. I don't understand it. How could that work? Let's run our tests. Make test base logic files equal. I wrote this whole test case for this thing. Let's see if it's gonna work or not. So why is this exploding with logs exactly is the question. Oh, because things panicked. All right, so A is an alias type. It cannot be modified. Interface conversion, blah, 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 blah. Okay, so this is failing when I try to, so I wrote a test case that validates that I can actually drop, or that I can fail to drop the type, right? So I really want to get this error. Blah is an alias type and cannot be modified, because you shouldn't be able to drop a fake virtual record type thing. And instead of happening that way, it's gonna just panic right now, which is not cool. So let's figure out why that's happening. Let's figure out why that is happening. And so what it's saying is that it's the wrong type. So I guess let's go ahead and see what drop type does here. Ah. So what happens is it says resolve mutable type descriptor. I guess here's the ultimate question is like, what do we say when we run resolve mutable type descriptor on an alias type? I suppose what I could say is just, no, cannot do that. Not allowed. Because I am a unmutable type, right? I could just return an error when somebody tries to get a mutable version of me, which seems legit, right? Maybe. Resolve mutable type. So right here, we can say switch desk.type, case type desk.mutable. Return prefix desk. I guess we can say switch t default. Default, we're going to say return nil errors dot new. I guess it's sort of an errors dot. It's actually like a very specific error. It's kind of tricky though. Let's just for now say error. We'll say pg error dot new f, and the code will be pg code dot. It's like, is there a mutability thing or modify? What happens if you try to drop like a system type in Postgres? Drop type int set verbosity verbose. What error code do they like to use here? It's 2bpo1, which is going to be error code dependent object still exists. Okay, sure, whatever. It seems a little wrong, to be honest, but whatever. We'll just use it for now. We're gonna say cannot modify immutable type. And we're gonna pass in the name, pass back the name called desk.name like this. So prefix is a resolved object prefix.
Computers hooked into over 1,000 data banks throughout the world.
All right, so let's go ahead and rerun these tests, see what we get. Thanks for the follow. All right, so the new thing is that we get a same thing in the same place. So did that just not work at all is my question. It says it's a virtual table record type, not a type desk.mutable, and we do that in line 170. Oh, it's actually in here, so that's kind of interesting. So it's actually not at this level. I think we can keep this switch. It's actually quite weird. So 223. I see. If it's a did I do this or was this here earlier? If I want to type and I see a type descriptor, what is the change here? Annotate previous revision. Oh, before I just casted it directly.
The data bank's too big. I have to narrow down the search. How are you going to do that? By guessing.
I think why do I need to cast this at all? This doesn't make any sense to me. because this whole thing is returning a this is just returning a catalog.descriptor. So why do we cast all these things? I guess it's just to assert their types. But we actually are asserting the interface type, which is better. So we're actually going to keep doing that rather than doing anything weird. So we're just going to say return obj dot type desk dot descriptor or whatever, type desk dot or catalog dot descriptor. That's going to be a bit better. So we're going to get rid of this stuff. Prefix nil, like this. We're going to get rid of this altogether. We're just going to get rid of all of this stuff. It's just not so necessary, frankly. It's just not so necessary. I think that's fine, right? Or is it not fine? I don't know. I'm confused. Quite confused. What did this thing look like before? Previous revision, what it looked like was... I think we just want to revert to what we had before, honestly. I think the weird thing that we're doing here is this. This doesn't seem to make any sense to me that we would do this cast. It doesn't seem necessary. So I think I'm just going to keep this, but change it a little bit. Get rid of this. So we're going to have, if it's a type descriptor, if it's not a type descriptor, we leave, and it's very confusing and sad for us. And we're just going to delete this altogether. And then I think we're going to be good to go. Except all of this is completely unnecessary. Because we're already doing... Oh, no. It's not necessary. But I think this part is unnecessary. Okay. All right. Okay, we're good. Let's try again. We're trying again. Adrian. Welcome, Adrian watchers, to the other CockroachDB stream. Hope you had a good stream, Adrian. Thanks for the raid. Thank you for the raid, indeed. So did you guys have the success? Did you have success on Next.js, Netlify, full stack stuff? Did it work? Tell me all about it. What did you find? Did you have any corgis bouncing about as one does? Define success. I mean, success could be anything, really. Success is, I think that's up to the eye of the beholder, right? I think that's up to Adrian. A raid is a success. Raid is that's a thing that one could do on the Twitches, and I think it worked. It absolutely worked. The raid came through. The raiders raided. But anyway, welcome everybody. Welcome in. I do want to know about the Next.js Netlify stuff, though. I'm very keen on knowing that, and because let me tell you something. Actually, it's very relevant to what we're doing right now on the stream, which is trying to improve compatibility with this thing called Postgres with a T. Netlify, really, you want to be able to use a regular old REST API in Netlify, but normal SQL databases don't really have a normal REST API. So there's a few ways to get around that. One of them is this thing called Postgres, which gives you an API on top of a database. And I think that we can conceivably get closer to having that be a thing with some of this work. Prisma, another thing that we would like to support. Prisma. And Hasura, also another thing that we would like to support. I want to use Prisma. Well, me too. Me too, frankly. It seems so neat. It's like hot stuff, Prisma. It's like, it's definitely on fire right now, I would say. So what do we get now is we get cannot modify immutable type, which is great. We just don't have a name for it, but that's an improvement. That's an improvement. Ah, I used the wrong call. That's going to be the issue. Okay, so we're going to try this again. Okay, so my tests are now failing because I've changed the error message, but I think that's actually fine. And I should just, you know what? I probably want to make this a quoted thing, but then I can go ahead and edit this guy to be the right error message, which is going to be cannot modify immutable type A. And, you know, to be honest, we could probably even just make it specific. Cannot modify table record type A, right? I guess I should be more specific too, right? If it's a type desk dot mutable, we don't have a public struct name for this. Let's just rename this to be capital V, so it's public. Cannot modify table record type, right? That seems fine. We don't need to have that virtual name in there. That's kind of weird. And then otherwise we'll just return what? What do we return at this point? We'll just return a assertion error, probably, right? Assertion error. Errors dot new assertion error. What is it? How do I get a new assertion error with wrapped error F? That's like too long and complicated of a thing, and I don't want it. Assert dot with assertion failure. Oh, right. So there's a package called assert. Assert dot new. That's not right either. I am confused. What is the name of this stupid assertion error package? Why can't I remember that? Errors dot assertion failed F. Okay. So it's errors dot assertion failed F. Unknown type descriptor type. I guess it's really more like unhandled. Unhandled type descriptor type S during resolved mutable desk. Then we're going to pass in t dot. I guess we just pass in t and then make this a capital T format string. You guys like that capital T format string? I like it quite a bit. You can go if you pass %t into a format string, capital T, it's going to actually give you, it's equivalent to saying reflect dot type of and then passing an object. It's kind of a nice little trick for debugging stuff. Okay, so let's try again to run the test here, see what we get. Okay, so now we got some good old exciting panics, which is good. It's very good. It's very, very good. So what is going on here? So this is during the test case called So this is where we're making tables that we shouldn't be able to make. So ultimately the point of some of this stuff is that we're making these virtual record type things, but we don't actually want to be able to use them in table definitions because we're just not like really ready for that. You know, we're not really ready for it. We're kind of trying to just keep the relationship casual, you know, don't want to have these things really get persisted ever. So we'd never want this to be able to happen. We want to return an error message when this happens. But instead of returning an error message, we're just crashing completely, which is very, very fun. And it makes sense that we're crashing completely because I think that we just don't have a case for some of this. So add backrefs from all types in table. Add backrefs from all types in table. And this is happening because we're running let's just take a look at this. Add backrefs from all types in table. Add backrefs from all type of table. Okay, so ultimately, get all referenced type IDs. At some point, this should fail with a proper error saying that we're not allowed to have any type references of this sort. So I think maybe in here, I think actually we are kind of trying to do that, but we get into a weird state at some point. So get all referenced types in table columns, and then we call add backrefs from all types in table. Get all reference types in table columns, right? Get all reference types in table columns. And then it calls something called, oh, I see. It calls this get type guy, which is implemented by somebody else. So this thing is actually implemented by add. What is this implemented by? Drop type line 199. So it's actually, it's interestingly, don't exactly understand that. Oh, this is a closure. I see. This thing is a closure. I see. And then we call it get mutable type version by ID. And the point is that just as before, we need to make sure that we cannot, this is not a thing. So we need to basically do the same thing that we did over here where we add a type switch and fail. So I think we kind of want something like this. Return desk nil. If it's one of these, then we're going to return something different. Yeah, so what do we do? If we try to return a mutable type ID, it's like cannot modify table record type, blah. It's basically what it is. So it's just going to look, it's going to come out looking a little weird. So we're going to have to adjust that. But that's okay. That is okay, actually. So I think this is a good thing. I think we're going to get back a test that does return an error, but just the wrong error now. So what we get back now is expect table record type B not allowed in definition. And now we're getting cannot modify table record type B, which is kind of true and kind of confusing. The truth is that what we should really do is like notice this error and then convert it into something more useful. It's a bit tricky to do that properly, though. It's a bit tricky to do that properly. I don't know how we're going to do that properly, to be honest. Because what we really want to do is say, like, at what level is that even going to be done? Get mutable type version by ID. Like, so many things could possibly fail here. And we cannot change the error message to be more specific at such a low level one. Yeah, I don't quite know what to do. I think what I want to do for now is just make the error message look weird and then solve it later, I guess. Do you think that generics could be better in this type switch stuff? It kind of depends on the use case. I don't mind the type switch stuff, so I'm not sure if it will get that much better, but I guess we'll see. So that's actually all the test cases, and they all pass now. So it'll be interesting to see how generics are incorporated into giant existing code bases. Yeah, I don't know exactly what it's going to look like. It should be interesting, for sure. I don't know how it's going to work in Cockroach, for example. I'm not sure. I mean, there's a few very specific use cases that I could see using generics for in Cockroach, but not like a ton. And I do wonder what it's going to look like to slowly propagate those around. But yeah, it should be interesting. It should be interesting. Could it be fun? Could be horrible. I don't know. So there was one other thing that I wanted to try to add a test for. Called testing to ensure that when we have a tuple type with an enum type and the version on the enum type changes, that we properly detect that the query is stale. Okay, so maybe the idea here is going to be, let's make a new make build short. I think the idea is that we make a enum type. We add the enum type to a table. And then we edit the enum type and make sure that any prepared statements that reference the old tuple type are invalidated or something. Something like that. Okay, so let's see what happens. So we're going to create table. First, we're going to make a type. So we're going to say create type A as enum AB. Create table foo. A int primary key. B A. Insert into foo values 1A. Select star from foo. Okay, so then the trick is that we can say something like select one blarg and then cast this thing to Phew. This should fail. Okay, it does fail. That's cool. Invalid input value for enum a blarg. So since the enum only has a and b, this should work if I put b though, and it does. And then this thing should also all be workable if I cast this thing later to b. Okay, so then the question is, let's say we were to say, prepare x as select 1, and then the, what do you call it? What is this thing called? The placeholder 1. And then cast this thing to foo, and then select out the b or something. Could not determine data type of placeholder 1. Okay, that's fine. We can just turn this into a string. Let's see if this works at all. So if I say execute x of a, and if I said execute x of blarg, this should fail. Okay, cool. Invalid input value. Okay, so now I've got this prepared statement. I think the question is, if I were to say alter type a, can I delete an enum value? Is that possible? How do I CockroachDB enum? Drop type, add value. I guess I can't delete a value, huh? Can I actually not delete a value from an enum? Alter, can I say alter table A, alter type A, drop value B? That's not allowable. It's an alpha feature. Well, let's stop working. It can enable it. All right, well, what if we just add a new value called C? What happens to my prepared statement? Is it still, what happens to it? Does it doesn't get, yeah, so this is definitely broken. So what's happening here is that the old type is still cached for some reason, which is kind of mind blown moment. We need to make sure that we detect that the version of this. What is this? Okay, so basically we have a table that references a type, and the type changed. And normally when you change a table definition, any prepared statements that reference it need to get refreshed. So the cache is dropped and it rechecks the table so it can get the right thing. But that's not happening here. This thing is still cached least or something. So it's giving back the wrong value. Whereas I think if I were able to just do select, hopefully if I just do this on its own with C, that should work, I think, because there's no cache, yeah. In general, I actually don't know how this is supposed to work. Does this work? So let's say if I said prepare blah as insert into foo values 1, placeholder 1.
Like you said, a human being.
And then I said
I wanna
execute
make it
blah
take
of
that chance.
C.
Why I wouldn't let her stay.
All right. I guess there should be 1, 2. Deallocate blah, prepare blah. Okay, so now if I say execute blah as 2, C, this should work. And if I did alter type A, add value D, and then I did the same thing with D, does this work? This doesn't even work. Okay, so we have a deeper problem here, actually. We definitely have a deeper problem, which is that we have a deeper problem, which is that there's something broken for this stuff already. I'm going to write about this just real quick on this issue. So we're going to make a very quick reproduction called create type A as create type T as enum A. Create table tab as create table tab tt prepare x as insert into tab values $1, execute x of. Okay, so then what we're gonna do at this point is say alter. We're gonna make sure it works at all. So we're gonna say execute x of a. Then we're gonna say alter type t add value b. And then we're gonna run execute a of b and watch it fail. Okay, so this is the concrete reproduction case that we're gonna quickly write down into this issue. Okay, so I've redone the PR to have a virtual descriptor. With no backing protobuf type desk. I was writing tests for the case there's a small, let's see, so how do I say this? I'm gonna say basically that while testing, I'll just requote this basically. So testing this, it seems like it doesn't even work for ordinary prepared statements against tables with enum types. So I'll file another issue for that. I'll just make a new issue. I've filed a separate issue for that. Let's make a new issue here. So this issue is going to be called SQL prepared statements not invalidated, prepared statements against tables with enum types not invalidated when enum changes. Okay, so here's the problem. I'm just going to basically just going to copy paste this thing. And I'll actually make it, I'll actually just delete this shell stuff so that it's more easily copy pasteable. So the following sequence of commands should either work properly or at worst, yeah, should work properly, but instead return an error. The issue is that the issue seems to be that the prepared statement doesn't notice that the table that it's referencing has an enum type that got modified, and causing it to refresh its referenced descriptors. Let's keep it as 1. I'd expect that this should work fine, or at worst, the error should be about the prepared statement being out of date or something. Okay, so this is a bug. I'm gonna put this in the schema project like this. Okay, so take this issue number and I'm going to paste it into here. Okay. So I think I'll basically I think I'm gonna make a new commit for this actually. SQL redo virtual type desks to be redo table record types to be virtual. I'll squash this before merging. This commit updates the record type prototype to use a virtual type descriptor that doesn't have an embedded protobuf type descriptor at all. There are a few to-dos that I'd like review input on. In particular, I want to decide whether or not we should be embedding the table descriptor what's up, Hydron, that the virtual type descriptor is aliasing. The commit currently does that, but I could see arguments for why we'd want to denormalize the fields into the virtual type descriptor struct. Not sure what we want to do philosophically, so leaving it as an open question. Okay, so we're just going to go ahead and push this. We're going to copy this message into the thing I just pushed. For now, it's in a separate commit for ease of reviewing. I'll squash once we get closer to deciding what method we want to use here. All right. Well, I think this is a pretty good thing. Pretty good success rate, you guys. I think we did 2 projects. We kind of fixed this up as much as we wanted to. We pushed the resulting thing for this as well. I hope this is going to be basically ready to merge at this point. And then we also did another thing, which is we fixed this bug in the preserve tuple types with decoding thing. So let's see if we can fix any problems with this guy before we bounce. But I think after this, I'm probably going to call it. So let's go ahead and check out fix tuple label erasure.
I have to narrow down the search. How are you going to do that? By guessing.
Column type encoding. It seems redundant. A.new dtuple. It's actually, it looks redundant, but it's not. It's not actually redundant. It does look it, but it's not. The one below is the datum alloc call, which needs a fully created tuple type, a tuple datum passed in. And you can't construct a tuple datum with type information without using tree.new dtuple. Conceivably, we could add that capability to the datum alloc call, but I think it breaks the normal pattern, which is just passing in a fully fledged datum that wants to be allocated to the heap. Okay, so just a quick response there. And then what is wrong with the tests here? Or is it just a flake? It looks like it might just be a flake, potentially. It's kind of like a weird looking, a 502. Okay, so I think this is just a temporary flake. So I'm just gonna leave that alone. And yeah, I think this is basically it. I think I'm gonna call it, you guys. Gonna go have some dinner with some friends. There you go. But I hope you had a good time hanging out. A bit of a shorter stream today, but thanks again for chatting and hanging and everything. Perfect time for tuning in. Yeah, basically, Dominic. Thanks for saying hi. But yeah, we're just about to bounce. But I hope you're doing good yourself. Yeah. See you later, Alan, as well. Okay, so let's go ahead and actually find somebody to raid. Before we leave, we don't want to leave before we find somebody to raid. We want to do that before we leave, of course. I should wash it more often? Oh, you're saying that, oh, okay. You're saying that it looks good because I just washed it, or you're saying that it's dirty even after I wash it. I'm not sure if I'm getting nagged or complimented right now. But either way, I appreciate you. Either way, I appreciate you. Why don't we go ahead and raid? Who do we raid? Let's go ahead and raid. Who's this? Jamie Pine.
So, which is unfortunate for me.
I haven't seen this person, but they seem pretty cool. So let's go ahead and raid this person here, Jamie Pine. They seem pretty cool. But
subscription.
Yeah. All right, y'all. Have a great weekend. I hope you do something fun. Get outside, exercise, program, play games, whatever it is that you like to do on the weekend. I hope you do it and have a very good time at it. I had a lot of fun today. I hope you did too. See you guys next week. Bye-bye.